The 27th of December 1571 witnessed the birth of a great astronomer and mathematician, Johannes Kepler, a genius who revolutionized astronomy and whose work contributed to the development of modern physics. Kepler assumed that there are exactly 6 planets and claimed that the distance from the Sun to each planet is the radii of inscribed or circumscribed spheres of various regular polyhedral shapes. Kepler's collaboration with the well-known Danish astronomer Tycho in studying the Martian orbit led to a huge advancement in science, for it actually led to one of the biggest revolutions in astronomy. Indeed, Kepler's observations of Mars' orbit and Earth's movements made him draw some crucial conclusions that made of him a pioneer in astronomy. These conclusions are the 3 laws of planetary motion, mathematical relations that can be applied to any system in a gravitational milieu. It occurred finally to Kepler that the difficulty that he faced in studying the Martian orbit was due to an error made by Copernicus. In fact, Kepler, who always revealed his very firm Copernican position, was obliged then to falsify Copernicus' assumption that the planets' orbits were circles. This discovery made him formulate his first law of planetary motion in 1605. The first law, or law of ellipses, is about the planet's orbit's shape. It states that the celestial motion is not uniform, and most importantly that each planet's orbit around the Sun is an ellipse with the Sun at one of its foci and with the major axis at its largest diameter. This law implies that the Earth-Sun distance varies as the planet goes around its orbit. In 1609, Kepler enunciated his second law, or the law of equal areas. This law states that for equal time intervals, each planet sweeps equal surfaces. This law also implies that the nearer the planet is to the Sun, the faster it moves. In 1619, Kepler enunciated his third law, harmonic law. The law states that the square of a planet's period of revolution is proportional to the cube of the semi-major axis of the ellipse. Put in other words, the ratio of the square of the revolutionary periods for 2 planets is equal to the ratio of the cubes of their semi-major axes. This law implies a direct relationship between a planet's revolutionary period and the radius of the orbit. The period increases when the radius of the orbit increases. For instance, Mercury, the innermost planet, takes much less time to orbit the Sun than it takes the outermost planet, Pluto, to orbit the Sun. The third law then implies that the distance planet-Sun can be calculated if the planet's period of revolution is known. Kepler's 3 laws were really put to test in his last enormous book, the Rudolphine Tables. This book helped astronomers observe the predictions put by Kepler in his tables with the actually observed planets, Sun, Moon, and compare the results with those of rival astronomical theories. Most astronomers became then in favor of Kepler's laws. Kepler didn't only contribute to the development of astronomy, he is the founder of the celestial physics, and his laws played a major role in the development of physics, for they influenced Sir Isaac Newton and helped him formulate his own laws that revolutionized physics. In fact, Kepler is an example of a great scientist who didn't merely add to one scientific domain, but to many at once. Kepler was one of the great astronomers who contributed enormously to the advancement of science throughout history. Galileo was a great astronomer and a contemporary of Kepler too. They both were aware of each other's ideas and work. In fact, letters were found confirming that they corresponded with each other about science.